Hi guys, I hope you're doing great. In this video, we are going to discuss the Codeforces round 884 that was ready for Dev 1 as well as for Dev 2. So we'll be going through the first four problems, that is subtraction game, permutation primes, particles and row major. So let's get started with the very first problem. That is a subtraction game. And here's the problem. So the problem states that you are given two positive integers a and b, and a is less than b. So what they want you to do is that there would be a there would be a pile with n stones. Now a person can remove either a stones from it or b stones from it. Then the next person would play, or the second person would play, and he can also remove a or b stones from it. It has to be exactly a or b. It cannot be some other number, right? So now you have to form this particular pile in such a way that the person two always wins. So how would he do that? Now very easy solution to this is that since we want the person two to win, hence we'll just make a pile of a plus b stones in total, right? So what would happen in that case is, let's say you make the pile, and now the very first person, so let's just show this. Okay, so you make a pile n, let's say, right? And the first person chooses a stones from it, then the person we can choose b stones from it, and the pile would get empty only if n is equal to a plus b, right? Now there could be another scenario wherein the person one chooses b stones from it, and the person two can now choose a stones from it, making the pile empty and hence winning the game. So the answer was simply a plus b for this. Here's the code for the same. Take two integers and just print this out. Cool. Let's move to the next problem. The next problem is permutation and primes, also a kind of simple problem. So the problem states that they firstly define what mix is. If you don't know, mix basically is the smallest positive integers that is missing from a set given to you. For example, if I say the set given to you is maybe like 1, 2 and 4, so 3 is actually the smallest number missing from it. So yeah, 3 is your answer. So what they define primality of an array or of a sub array as the number of pairs, right? Of primality of an array is the number of pairs L comma R such that L should be less than equal to R. That's obvious, right? And the mix of all the numbers inside this particular segment from L to R is a prime number. Now what does this mean? This basically means, let's say you have numbers 1, 2, 4, as I gave you the example. So the primality of this particular array, or the you can say the mix of this array, would actually be 3. Now is 3 a prime number? Yes, 3 is a prime number. So we can add 1 because of this array. So that is what they stated. And now they asked us that they'll be giving us a number n, and we have to give them what is the best sequence so as to maximize this primality. Now how do we go about this problem? There's a very trivial observation over here. So let's say if you don't have a 1 in a subsequence or in a sub array, then the answer always is 1 of that array. For example, if you have like, let's say 2, 3, 4, the mix of these numbers is 1, right? And since 1 is not a prime number, hence you want to include 1 always, right? Now what are the other prime numbers that you can use? You can use 2, you can use 3, right? So what you want is that 1 should be in most of the arrays. Now it's not always possible because if you have an array, right, you can you'll have 1 only once, right? So there would definitely be arrays wherein 1 is not present, but you want to minimize that number. So obvious choice is to keep 1 at the middle, right? Now what? We already have 1 at the middle. What we can do now? Now I can say that whenever I'll be going to this side, right, or whenever I'll be going to the left side, then my mix would actually be greater than 1. But greater than 1 are many values, so I don't know exactly what would be there. So I can say let's just put a 2 over here at the very beginning, right? If I put a 2 at the very beginning, that basically what it would do is the mix of all the sub arrays starting at this point going up till here would actually be 2. And let's keep a 3 over here. Now why I'm doing that? Because now if you travel till 2 also, so if you go from L, so let's say this is R and this is L, right? Even if you traverse the entire array from L to R, still your mix would be 3. And if you travel in any other subarray that is ending at R but starting at any other location, then your mix would be 2, right? And both 2 and 3 are prime numbers. Similarly, over here, if you start at L basically being your mid number, that is 1, and you start traversing towards right, then till the time you reach 3, your mix would be 2. Because 2 is already present over here, right? So the mix always would be 2. And once you reach 3, still the max would actually remain 2 only. So the max is always 2 towards your right, and towards your left your max can be 2 or 3, which are both prime numbers. The only condition being that it should start from 1 itself. Right. Now this is fairly simple to understand. Let's look at the code. This is the code for this. Yeah. So you can actually remove it. Because there's an edge case, right? Because let's say if your like the value was maybe like just n is equal to 1, the simple answer is 1, so I can't print 2 over that, right? So that's why I've taken this. But yeah, you can actually optimize it a bit, but anyway, this actually works, so let it be. If your n is equal to 1, then the answer is 1, 2, then the answer is 1, 2, 3, the answer is 3, 1, 2. But then in other cases I'll just print a 2, then I print the elements that are to the that are in the range from 4 to n by 2 plus 2, right? So I want to print half of the elements that are in the range of 3 to n, right? And the remaining half I'll print over then I'll print a 1, and then I'll print the remaining half. This is similar to this, so I'm printing a 2, then the remaining half, and then n, sorry, not n but 1. Okay, then 1, and then the remaining half, and then 3. I hope this makes sense. Now the way you are gonna put the elements over here can be random. It won't actually matter because your mix never would depend on these, because the smallest number mixins would always be 2. Similarly in this case, mix never would depend on these, so you can put any elements in any form, but just going through a while loop is fairly simple, so I did that. Cool. Now let's move to the next problem. The next problem is I'll not say it's tough, but it's kind of those problems that if it doesn't click, then it can like consume a lot of your time. So the problem states that there are particles in a line. Now the particles, you can pick a particle, right? Remove it. For example, they remove -1 from here. The particle just to the left of it and just to the right of it now would combine to form a combined charge. For example, over here now 4 and 5 would combine to produce a charge 9. So yeah, these combine and now they produce a charge 9. On the other hand, if the element you are picking or the element you are removing is present at the end, then nothing would happen. For example, I can just simply remove 3 from here and simply remove 10 from here. Fair enough. And at the end, we have to perform these operations in such a manner that only one element is left, and we want to maximize the charge on it. For example, in this case, I can have the element 9 remaining. So I can say once, so this is trivial, or this is already shown that how we get to this particular point. Firstly, we get to minus 3, 1, 9, -9. Then we can remove -3 and -9 from here, right? And then we'll be left with the 1 and 9. Then we can remove 1 from here. Then we'll just be left with a 9. That is a valid answer. That is actually the answer for this problem. Cool. Now, how would we generalize this? So very simple observation over here is, let me just switch to the iPad. Yeah. So very simple observation over here is that the elements at the odd locations. So let's call the elements at the odd locations as O, and the element at the even locations as E. So O, E, O, E, O, E. Now the claim I'm giving is that your elements at even location can only and only combine with the elements at even locations. Now, how can I say that? Let's say you remove this element, right? You remove this, then this E, let's draw it with a different color to signify that. So this E and this E would combine, right? Interesting. Now what would happen if I remove this E? If I remove this E, right, then either, okay, let's simplify it. Let's say I remove this E, then basically this O and this O, that are two odd locations, would combine, and this would be a mutual process, right? But can I remove? So in other terms, I can say that the final answer would actually be either sum of all numbers at odd locations, right? So in that case, you can say that, okay, I'm gonna just keep removing all the elements at even locations and the remaining elements. So for example, over here, let's just draw it just to understand it a bit. Let's say there were these 4 elements. So this is odd, this is even, this is odd, this is even, this is odd, right? So firstly, I say that, okay, I'm gonna remove this this even. So cool, I'll remove this. As soon as I remove this, these two actually combine, right? So let's combine these. Let me just place one top of other. Cool. These O's combined, and now I'll remove this E. So as soon as I do that, then these two O's combine. So basically it becomes the sum of all the three odds, right? And in the same fashion, I can do it for even as well. So it is either gonna be the sum of all odds or the sum of all evens, right? But what's the edge case over here? Now it could happen that one of the numbers present at the odd location is negative, right? I want to check what is the maximum sum I'm getting by combining all the elements at the odd locations. What shall I do in this case? In this case, I can say that I can always remove it. Now, wouldn't that disrupt our theory of odd and even? It actually won't. Let's say we have odd, even, odd, even, odd, even, right? Now, let's say this odd was actually negative and we removed it, right? So we removed it. As soon as we remove it, this would get removed and this even, okay, let's pick it up. This even and this even would combine, right? Now it again becomes the same sequence. So now it just becomes OE OE. It appears as such there was no O at this place in the very beginning itself, right? So the negative odd is actually removed, and on top of that, it doesn't changes anything about the pattern. So the pattern still remains OE OE, or it's alternating between odd even, right? So using this thing, we can say that the answer always is the combination of, it's always the combination of either the odd indices or the even indices. But over here, you have to mention the only the positive ones, because the negative ones we can remove. Now, only edge remains is that what if all the numbers are negative? All numbers are negative. In that case, the answer cannot be zero, right? The answer cannot be zero because at the last we're gonna left with some. We are gonna be left with something, right? So in that case, I'll just take the number which has the least negative magnitude, the number which is actually the biggest amongst those. Cool. So let's look at the solution. The solution is short for this. Let me open this. I have no idea why there's a squiggle over here, but anyway, I think everything's cool. I don't know why there's a squiggle. Okay, so firstly, I'm taking the maximum element. I actually have divided over here. So I'm just getting the maximum element from this. So once I have the maximum element, I'm storing it in result. Then I'm making two arrays or two vectors. You can see even and odd. I'm just pushing them into this. Once I'm done with that, then my result would be the maximum of result. Or if the odd has some size. Now why I'm doing this? Because if I don't explicitly that if it has a size or not, then what might happen is that or what would happen is that it would actually give answer 0. But answer 0 might not always be true. For example, in this case, wherein there was just one element that was negative, the answer has to be negative itself, right? So that's what I'm checking. If the it has some size, then I'll try to sum it up. Else, I'll just say that return result, and then I'll do the same for evens as well, right? And I'll just print the result. Cool enough. So that leaves us with the very last problem. That is, let's open that. Okay.
So let's begin with the fourth problem. So there is a row major order of an R cross C grid of characters. A is the string obtained by concatenating all the rows. Okay. So if there is a matrix with R rows and C columns, and if we concatenate all the elements of the R rows in a single row, then that is what we will obtain. So a grid of characters A is bad if there are some two adjacent cells with the same character. Okay. So there should be no same character in this. There should be no same character shared by cells which have common edge. That means if there was a matrix and let's assume that there is a character X here, X should not be present here, neither here, nor here. Okay. So we need to find the minimum number of distinct characters we require to form a matrix. To form a matrix that is not bad, that is, it does not have any cell whose adjacent cell has the same character. Okay, so how can we proceed? So let's assume that the number of elements in the matrix is capital N, and we can always represent it in the form of n into m, that is the number of rows and the number of columns. Okay, so we can break this into two parts. If n is odd and n is even. Okay, if n is odd, what can we say? We can simply conclude that the answer will be 2. That is, only 2 elements would be required to distinctly create such a matrix. Why? Because since n is odd, and therefore n into m will also be odd. Okay, so if there is a grid which has odd number of elements, and the first element is, let's say, a, um, the index of this element is 0, and the index of this element would be 0 plus c. Okay, so since c is odd in all cases, I can say that if I keep alternating the sequence a b a b a b, a will always be followed by b in both the directions, and so will b be followed by a in all the 4 directions. Okay, so in case n is odd, we can simply consider that the answer that only 2 characters would be required, and we can alternatingly put the characters. Okay. So now the other case, in case when the value of n is even. So what do we need to do in that case? In that case, n and m both can take even as well as odd values. Okay, so if there is a grid and the first element is 0, this index of the first element is 0 in the string, then this would be 0 plus c. Okay, so 0 plus m, let's assume that there are m number of columns, so the index of this element would be m. Okay, so what do we need to ensure? That the adjacent characters are not the same. Okay, so what can we do? If we, so what are the possible values of m? M can take all the possible numbers which are factors of capital N. Okay, since I'm writing n as small n into small m, so m will definitely be a factor of capital N. Okay, so if I store all the factors of capital N in a set, and okay, we'll deal with this later, and let's assume that I required 4 characters to get the answer. Okay, so let's assume that after 4 characters, this is the case, and a is followed by b and c, and a is followed by d in the downward direction. So how can I create the rest of the grid? If I keep repeating the above sequence multiple times, I can observe that A is still followed by B in right, A is still followed by D in the downward direction. Okay, as was the case here. And similar is the scenario with all the characters. B is followed by C in the right, and B is followed by A in the downward direction. And in all the upcoming rows, B will be followed by C in the right. Here, when the row changes, it goes to the bottom and would be followed by A in the downward direction. Okay, so once I figure out the minimum number of characters that can get me an answer, I can simply repeat it up to n, and whatever the string will be obtained can be my answer. Okay, so what should I do? I should find such a character. So let's assume that I always start with A and I go up to some character k. That is, I have k distinct characters which are required. Okay, so what can I say about the value of k? Okay, so if there are k characters, then what will be k characters, and there are c elements and there are c columns. Okay, so what will be this character in that case? The one which is followed by A in the downward direction. That would simply be A plus C, A plus C, if we convert it into a character form, then this will be the answer. Okay. So if this value is not equal to a for any value of c, then can we say that that would be our answer? Exactly not c, because it might be the case that uh, the characters repeat multiple times in a single row as well. A, B, C, D, A, B, C, and then D in the next row. Okay. So what can I say in this case? I need to take the modulo with C modulo with K. K is the number of the character. Like A is 1, then 2, then K is whatever number corresponds to that. So I can take that. And for if any factor of n satisfies this, then I can definitely not get an answer with that many number of characters. Okay. So I can first assume that k is 1, that is equal to a. Then I can assume that k is equal to b and check it for all factors of n using this formula. If I get any such value, then if I get even one index which is satisfied by this equation, then b will not be my answer. Then I can begin with c and d and continue up to z until I get my answer. Okay. And once I get a character that satisfies this condition, then I can simply repeat this character n number of times until I produce the answer. Okay, so let's have a look at the code. So this is the code. I've taken the value of n as input, and if it's odd, I'm simply alternating between a and b and printing the result. In case it is not odd, then I'm calculating all the factors and storing it in a set. All the factors of n and storing it in a set. And I'm assuming that k, which I said here, 0 means a. That is, I'm going from a to a. When I value is equal to 2, let's say, then I'm going from a to c. That is, I will use 3 distinct characters to produce my result. Okay, so I'm calculating this value, and I'm also calculating the answer I have to take mod with. Here, since I've begun with 0, I need to add 1. And if for any factor of n which I've stored in the set h1, uh, I get this result, that is j modulo no gives me equal to 0, because the first character is always 0. I've assumed that I've started with a in all the cases. Then the value of I is not sufficient to give me the answer, and so I need to begin with the next iteration. That is, I can assume that I'll need one more extra character and iterate until I find a number which does not satisfy this condition even once for all the values of j in the set. Okay, and once I've found the answer, I can simply print a, b, c up to k n number of times until I produce the string of length n.